Hey guys, welcome to the Solution Architect channel. And I first want to just start with apologizing for not uploading a video for the past 7 to 8 months. There's a lot of things we went through this year, and I think everybody went through a lot of things, with regards to the pandemic. We moved countries back to South Africa, and it took a long time to settle, but we also went through a personal family tragedy of 2 months ago. I'm not going to go into detail there, but I've also in this time worked a lot on Kubernetes, and that's the reason for this video, is the start of a series so we can go through step by step on what is Kubernetes. I think it's important to start with the architecture, and this specific video will focus on the components within Kubernetes and the architecture around Kubernetes. And then the next few videos will be how to install it, how to use it, and how to write an application, deploy it to Kubernetes. It's going to be local, not going to be in the cloud. I don't have subscriptions, and it costs a lot of money here from South Africa. So hopefully you enjoy my videos, and thank you very much for those that already subscribed. And if you're not, please subscribe, please like, and please share my videos. And I will actually do some videos that you also comment on, and I will get to that as soon as I can. This is just a quick interruption before we go ahead with this video. I've recently uploaded DevOps pipeline for Azure DevOps onto Udemy, and the course has been running for 8 months. It's doing well so far, and the link is in the description if you are interested in signing up for the CI and CD pipelines on the Azure DevOps platform. I've also recently uploaded a solution architecture practice type of course on Udemy, and you can also find this in the link down in the description of this video. So let's continue with this video. Sorry for the interruption. If you're interested, let me know. If you want to chat about it, let me know in the comments below. Hopefully the new year will be good for all of us. But let's jump into Kubernetes architecture. So let's talk about the Kubernetes architecture. So first of all, what you see in front of you is just a depiction of the different components you need when you actually set up a Kubernetes cluster. So the first thing that's important on here is the control plane. The components within the control plane make global decisions about the cluster. For example, it will allow for scheduling to happen, as well as detecting and responding to cluster events, such as starting up a new pod when a deployment's replica field is unsatisfied. The second thing is the Kube API server. The API server is a component of the Kubernetes control plane that exposes the Kubernetes API. The API server is the front end for the Kubernetes control plane, and that is how you access your Kubernetes services through the API server. The main implementation of Kubernetes API server is called Kube API server. The Kube API server is designed to scale horizontally. That is, it scales by deploying more instances of itself. You can run several instances of the Kube API server and balance the traffic between those type of instances. The next component is called etcd, consistent and highly available key value store, used as a Kubernetes backup or a backing store for all the cluster data. If your Kubernetes cluster uses etcd as its backing store, then you need to make sure that you have a backup plan available for those type of data. The next one is the Kube scheduler, control plane components that watches for newly created pods with assigned nodes, and then select the nodes for them to run on. The next one is the Kube control manager, which is basically a control plane component that runs the controller processes. The Kube controller manager, logically, each controller is a separate process, but to reduce complexity, they are all compiled into a single binary and then run as a single process. And these controllers includes the node controller, and the node controller is responsible for noticing and responding when a node goes down. So that will then act up on that node goes down and then spin it up again. The next one is the replication controller. It is responsible for maintaining the correct number of pods. So if you specify 2 pods or 3 pods or 4 pods, and then it will make sure that every replication of the controller object is in the system. The next one is the endpoints controller. It populates the endpoints object that joins the services and the pods together. And the last one, part of the Kube controller manager, is the service account and token controllers. And this creates default accounts and API access tokens for the namespaces that is used. So the next one that is not available in all instances, if you, for example, run your Kubernetes cluster locally, you won't have a cloud controller manager. But if you are running it, say, in Azure or in AWS, then you need a cloud controller manager. A Kubernetes controller plane components that embeds cloud-specific control logic for that specific cloud. Each cloud runs Kubernetes a little bit differently. The cloud controller manager lets you link all your cluster into your cloud provider's API, and it separates out the components that interacts with that cloud platform for components that just interact with your cluster. The cloud controller manager only runs controllers that are specific to your cloud provider. So, like I said, AWS or Azure or even Google. If you are running Kubernetes on your own premise or it's just learning environment inside your own PC, then the cluster does not need a cloud controller manager. Now let's talk about the node components. The node components run on every node, maintaining the running pods and providing the Kubernetes runtime environment. You've got also a kubelet. A kubelet is an agent that runs on each node within the cluster. It makes sure that the containers are running and up and running in a pod. The kubelet takes a set of pod specs that are provided through various mechanisms and ensure that the containers described in those pod specs are running and is healthy. The kubelet doesn't manage the container which were not created by Kubernetes. A kube proxy is the next component. The kube proxy is a network proxy that runs on each node in your cluster, implementing part of the Kubernetes service concept. The kube proxy maintains the network rules on the node. These network rules allow network communication to your pods from the network sessions inside or outside of your cluster. It also uses the operating system packet filtering layer if there is one and if it's available. Otherwise, the kube proxy forwards the traffic to itself. The container runtime is the software that is actually responsible for running the containers itself. Kubernetes supports several types of container runtimes. Like you probably know already that you've got Docker, you've got Containerd, you've got CRI-O, and any other implementation of the Kubernetes CRI, which is the container runtime interface that will allow to run a container runtime. So this is basically the high-level architecture of Kubernetes. I think it's really important for you to understand it. So when we start implementing and running code or containers within Kubernetes, you understand what the Kubernetes cluster are doing for you. Hope you enjoyed this video, and the next one will definitely go into more detail on Kubernetes.